Hello everyone, welcome to Shibe's chemistry classes. Today we have to do the preparation of salts. In the previous video we have seen water soluble and insoluble salts, and in this video we have to cover the preparation methods of both the types of salt. But before coming to the main topic, let's try to recall what are soluble and what are insoluble salts. So soluble, first we will see soluble and then we'll come to insoluble. So recall first, what was the first point? That all the compounds of sodium, potassium and ammonium are soluble. No matter what the compound with what polyatomic group they are combining, they all are soluble. Second, nitrites and nitrates. Nitrites and nitrates are also soluble with no exception. Third, all chlorides, bromides and iodides. All chlorides, bromides and iodides are soluble with three exceptions. We have learned three exceptions. One is lead chloride, silver chloride and mercury chloride. And out of these three, this lead chloride is soluble in hot water. It is insoluble in cold water, but it is soluble in hot water. So maybe you will get this question and name one chloride that is soluble in hot water. So that is lead chloride. So then sulfates. All sulfates are soluble except barium sulfate, lead sulfate and calcium sulfate. So these three sulfates are insoluble. And the fifth point was carbonates and sulfides. Carbonates, sulfides, phosphates and sulfides. They all are insoluble. But if it is a sulfate or carbonate, not sulfate, sulfides, phosphate or sulfide of sodium, potassium and ammonium, then they would be soluble. Because out of these 2 points, this one will hold true in all the cases. And no matter if it is carbonate, if it is sulfide, phosphate or sulfides. So these things you have to keep in your mind. And now one by one we will start the preparation method. So the first method of preparation is by direct combination or synthesis. Both are one and the same method. First is direct combination. Or we call it as synthesis. So in this we'll take a metal and a non-metal, and after combination we'll get the respective salt. So take a metal, say sodium, non-metal is chlorine, because the most common example of salt that we are familiar with is sodium chloride, and that is a soluble salt. So first method of preparation you can take sodium chloride only. So sodium and chlorine reacts and give sodium chloride. Balance equation. Sorry, this is NaCl. Let's make it 2 and 2. Next you can take iron. Fe is iron. Chlorine, you will get FeCl3. This is ferric chloride. So these two compounds you can make by direct combination method or synthesis method. So next we'll see by simple displacement. So what do you remember about displacement? A more active element displaces a less active element from its salt solution. So what is happening in displacement? More active displaces less active. And more active elements we know, they are sodium, potassium, zinc, aluminium, iron. So these are the more active elements. So in displacement reaction, you have to take one acid and a active metal, like say zinc or iron. Zinc, iron. One salt of zinc we know, that is ZnSO4, zinc sulfate. So for that sulfate group to come with this zinc, we have to take H2SO4. So react this zinc with sulfuric acid, you will get ZnSO4 or zinc sulfate plus hydrogen gas. Is it balanced? Zinc? Yes, it is a balanced equation. Second, we took iron over here, and one salt of iron we know. Ferric chloride we have already done in direct combination method. By direct combination method, you could prepare only ferric chloride, but here we have to prepare ferrous chloride. So that means chlorine group is needed. So we will take HCl. We will give ferrous chloride and hydrogen gas. So it is balanced. Now next method is by decomposition method. So you can see in product side, whatever compound or product you are getting, they all are soluble. Chloride, we have studied all the chlorides are soluble with 3 exceptions, and all the sulfates are soluble with 3 exceptions. And what are the insoluble sulfate? Calcium, lead and barium are the insoluble sulfate. But here what we have made? We have made zinc sulfate, so it is a soluble salt. Now next method is by decomposition method. So in decomposition, we will break a complex compound into a more simpler element or compound. So decomposition. So in decomposition, we will decompose bicarbonates, carbonates, chlorides and nitrates. We will decompose bicarbonates, carbonates, chlorides and nitrates. And we will decompose these carbonates with these compounds, or we can say polyatomic group, with acids. So the first we will see the decomposition of bicarbonate. Decomposition of bicarbonates. So one of the most common example of a bicarbonate we are familiar with is sodium bicarbonate. And one more, you can take calcium bicarbonate. Calcium valence is 2, so put 2 over here. So take HCl because we have to make sodium chloride. So you can take HCl here. And we know that whenever decomposition of carbonate group takes place, you will get carbon dioxide gas. So make one product as carbon dioxide, and then water is also common. And what salt you are going to get? That is sodium chloride. So this is how you have to write chemical equations. Most of the time you need not to learn all the things. You can understand the thing, how it is happening. And by now we have done so many common equations. So there is the very hardly Few examples are there that are entirely new, but most of the time you can see that we are repeating the same equation again and again. Yeah, so it would be simpler for you to learn. Second is calcium bicarbonate, and after decomposition, so calcium salt, you can make calcium chloride, you can make calcium nitrate. So if you want to make calcium nitrate, so you have to take an acid with nitrate group, so that is nitric acid. You can see this nitric acid is having a nitrate group. Then these two products will be same, and the salt that you will get is calcium nitrate. Valency of calcium is 2, so you have to put 2 over here. So we are studying decomposition method, in which the first is decomposition of bicarbonates, then we will see decomposition of carbonates by acid. Bicarbonates we have done, now we will see carbonates. Carbonates means CO3 2 minus. This is a polyatomic group and its valency is 2 minus. So you can take magnesium carbonate, and what else? Copper carbonate. Any compound you could take. Magnesium carbonate and copper carbonate. Now what acid? Just think of any salt with this magnesium. Magnesium sulfate you could make. So take H2SO4. Here you can take HCl. Because copper chloride is a salt. So to form copper chloride, we want an acid with a chloride group. So we took HCl over here, and we have to make magnesium sulfate. You could make magnesium chloride also if you want to make magnesium chloride. So you take chlorine, compound with chlorine. So that could be HCl. So just combine it. Two products we already know, that one would be water and carbon dioxide is the other one. Here also take water and carbon dioxide, because we are studying the decomposition of carbonates, so definitely carbon dioxide will be one of the product. Now the salt is MgSO4, that is magnesium sulfate, and copper chloride. You just keep on balancing the equation. So I'll make a separate video on how to balance a chemical equation and post it for you. See, in all these methods, what product you are getting? The salts that you are getting over here, they all are soluble salts. We are making this soluble salt from an insoluble one. See, carbonates, we have studied that all the carbonates are insoluble. So this is magnesium carbonates, which is insoluble. We have done the decomposition with acid, and what we got over here as a product, that is a soluble salt. Magnesium sulfate is a soluble salt. Okay, so because we have studied that all the sulfates are soluble except barium, lead and calcium. Calcium sulfate, barium sulfate and lead sulfate we are not making by this method because they are insoluble salt. What we made soluble salts. Next is decomposition of chlorides by concentrated sulfuric acid. By sulfuric acid. For this, you have to take example of chloride. You can take NaCl, ZnCl2. Why 2? Because zinc's valency is 2. Chloride valency is 1. So whenever you are writing the formula, you have to cross the valencies. Reacted with sulfuric acid. sodium sulfate and HCl gas. Here zinc sulfate and HCl gas. See, if the reaction take place above 200 degrees centigrade, then this will form. Sodium sulfate you will get as a product. If it is below 200 degrees centigrade, then this hydrogen, only one of the hydrogen will be replaced and you will get, see, I'll make it over here. If it is below 200 degrees centigrade and above 200 degrees centigrade. So above 200 degrees centigrade, both the hydrogen will be replaced and you will get sodium sulfate. And if it is temperature is below 200 degrees centigrade, then you will get sodium hydrogen sulfate as the product. This is sodium bisulfite and this is sodium sulfate. And here ZnSO4 and HCl. So this is decomposition of chloride by concentrated sulfuric acid. Next is decomposition of nitrates by concentrated sulfuric acid. We'll take one nitrate group and then react it with sulfuric acid. Decomposition of nitrates. Decomposition of nitrates. See, in decomposition method, we are taking sulfuric acid, that is the common reactant in all the cases. First we have studied bicarbonates, then carbonates, then chlorides, and then this thing, nitrates. Concentrated sulfuric acid. We'll take potassium nitrate, react it with sulfuric acid. So what you will get as the product? You will get potassium salt and KHSO4. This K and one of the H and SO4 will combine and you will get a potassium salt, that is KHSO4, and one of the H will combine with this nitrate group and you will get nitric acid or H1O3. So this is the decomposition method. In decomposition, we have seen four methods. First is the decomposition of bicarbonates, carbonates, then chlorides and nitrates. In the decomposition of chloride method, we have decomposed chloride compound with concentrated sulfuric acid. Now the next method is neutralization method. Next method of preparation is neutralization method. In this, two methods are there. One is titration, another one is neutralization. See, if the neutralization is happening with an alkali, you remember, base that are soluble, and a soluble base they are called alkali. We have studied NaOH, KOH, they are highly soluble, and this calcium hydroxide and ammonium hydroxide, they are bit less soluble as compared to this. But NaOH and KOH, they are highly soluble. So if the neutralization is happening with any of these, then that method we call titration, and rest all the methods are called neutralization. So we'll take examples of both. So neutralization, you remember, acid reacts with a base, gives salt and water. Take acid, HNO3 is an acid, react it with base, you will get salt and water. So this compound is sodium nitrate, and we know that all the nitrates and nitrites are soluble. So this method is called titration because what base we have taken over here, that is an alkali. Alkali means water soluble. So that is why this method is called titration. this is a base. We know that all metallic oxides are bases. So acid react with base, you will get magnesium chloride plus water, magnesium salt and water. So here the base that you have taken, it is not an alkali, and only these four are alkali. So sodium hydroxide, potassium hydroxide, calcium hydroxide and ammonium hydroxides. So these are alkali. So whenever you are having these alkali as one of the reactant in neutralization reaction, then we call it titration. And rest, if any of the base you have taken, you would call it neutralization. I hope what I am teaching you is getting clear to everyone. If I'm getting going very in speed, if I'm going in speed, then you could comment me and tell me that you have to slow down your speed a bit. Or if you are familiar with all these things, you can increase the speed and watch. So just make a note of it, then we will see the next method. Now, by the action of alkali on certain metals, their oxides and their hydroxides, by the action of alkali. So alkali, if I say the term alkali, then immediately both the examples would come in your mind. What examples? NaOH and KOH. And by the action of alkali on certain metals, like we can take aluminium, zinc, their oxides and hydroxides. So what method is this? By the action of alkali, NaOH and KOH on these metals and their oxide. Like zinc, its oxide is ZNO, aluminium, ALOH thrice. So we have to react this now. Zinc plus NaOH will take zinc oxide plus KOH, just take KOH. It is also an alkali. Aluminium hydroxide plus NaOH. So first zinc plus NaOH, you will get Na2ZnO2 plus H2. Na2, balance it, ZnO2. Here K2, ZnO2. K2, ZnO2 plus H2O. Balance it, K2, ZnO2, H2O. And the last is aluminium hydroxide plus NaOH. You will get sodium NaAlO2 plus H2O. NaO2 2, 4, 3, 4. So equation is balanced. So this is the last method, but the first four methods that we have studied, they are important from your examination point of view. So after completing this, we will do a question session also. We will take some of the questions from your textbook and we will practice that. So next method is the preparation of insoluble salts. So what are insoluble salts? Recall it once again. Insoluble. Chlorides of silver, lead and mercury, they are insoluble. Sulfates of barium, calcium and lead are insoluble. And all the carbonates, sulfides, phosphates, they are insoluble. So now we have to see the preparation of these insoluble salts. Now we will see preparation of some insoluble salts. Now try to recall what are insoluble salts, like chlorides. We have studied that all the chlorides, bromides and iodides are soluble except silver chloride, lead chloride and mercury chloride. So these three were the exception in chlorides. And we have studied that all sulfates are soluble except three sulfates. What are they? Barium sulfate, calcium sulfate and lead sulfate. Sulfides are insoluble. Sulfides, phosphates and carbonates, they all are insoluble except for sodium, potassium and ammonium. And what else? See, now we will see the preparation of these compounds. Insoluble. Preparation of insoluble salts. So the first method is by precipitation method. Precipitation method, or we call it double decomposition method. Precipitation or double decomposition method. So what we'll do, we'll take soluble salts of these compound, and then after decomposition we get insoluble salt from that. So see, I will tell you a trick to learn these reactions. Like suppose, just learn these examples. Suppose you have to make silver chloride. So write silver chloride as one of the product. Suppose barium sulfate. So you are desired to get these compounds on the product side. So write the products, like you could take lead chloride also. And what else? Sulfide, take one of the sulfide, copper sulfide. From what you can see here, this silver chloride contains silver and chloride group. To take one, now in the reactant side, you have to take compounds in such a manner that they could contain this silver and chloride group. So just take like silver nitrate. What you have to take in the reactant side, that could be a soluble salt of the following element. So take the soluble salt. We know that all the nitrates are soluble. To take silver nitrate, and to get chloride group over here, you have to take HCl, hydrochloric acid. So after reaction, what you will get? You will get AgCl, silver chloride as one of the salt, and HNO3 as the another product. HNO3 is nitric acid. Similarly, next you have decided to prepare barium sulfate. So on the reactant side, you have to take one compound that is containing a sulfate group. So just remember, try to recall what compound contains a soluble salt. That could be a soluble salt. So, and that could be a soluble salt having this sulfate group. So you could take sodium sulfate over here, and another is Ba. So take barium chloride. So after reaction, you will get barium sulfate plus NaCl, sodium chloride. Next, you want lead chloride. So take one compound containing lead and another compound containing chloride group. So lead, in place of lead, you have to take lead nitrate plus HCl. You would get lead chloride and HNO3. Now you want copper sulfide. Copper sulfide is a insoluble salt. Take a salt that is soluble, CuSO4, and H2S is hydrogen sulfide gas. You will get CuS and H2SO4. So H2SO4 is sulfuric acid. Make one carbonate. We have not prepared carbonate, na? So suppose you want to prepare lead carbonate. Carbonate is CO3. Take lead nitrate again, a soluble salt of lead, and to get carbonate, take sodium carbonate. Sodium carbonate, lead nitrate. So after reaction you will get PbCO3 and a sodium salt, NaNO3. Balance it. Balance all the reaction. It would help for practice also. So this is the first method of preparation of insoluble salt by precipitation method or decomposition method. Double decomposition method. Learn the names of the insoluble salt and write those names on the product side and just combine. Take one element. Suppose here it is silver, so just think of a compound having silver, and that could be a soluble salt. So silver nitrate is a soluble salt because we know that all the nitrates and nitrites are soluble, and to get chlorine you have to take HCl gas over here. HCl, hydrochloric acid. React it, just interchange the cation and anion and form the products. So eventually it will come with practice. Now second method is by direct combination or synthesis. It is the same method. We done this method in soluble salt also. By direct combination. Lead plus sulfide group, lead sulfide, and iron plus S, you will get FeS. So this sulfide group, that is insoluble. So lead sulfide and iron sulfide is an insoluble salt which is prepared by direct combination method. So this is the second method. And the third method is by the combination of an acidic oxide with a basic oxide. These two methods are very simple. The most important is the first method, the precipitation method. Rest two are not that much important. But maybe you will get in multiple choice questions, so you have to practice all. So the third method is combination of acidic oxide with the basic oxide. You will get the respective salt. We know that all the non-metallic oxides are acidic. Take non-metallic oxide. Sulfur is a non-metal. Oxide means combine it with oxygen, you will get sulfur dioxide. Carbon is a non-metal. Combine it with oxygen, you will get carbon dioxide. And all the metals form basic oxide. So say calcium oxide is a basic oxide. So you have to make an insoluble salt. So you will get calcium sulfite and calcium carbonate. Calcium sulfite and calcium carbonate. So this is all about the preparation method of soluble and insoluble salt. Now in the next session, we will be dealing with some of the important questions from your textbook. Till then, have a nice day.